Hi, so this is 7.6, graphs of the sinusoidal functions. This is going to be broken up probably into 3 different videos. So the first video, I'm just going to show you the graph of sine, and we're going to work with doing alterations to that graph. So before you start, please go find your unit circle, because we're going to need that to retrieve the values found below. So if you need to pause me, go ahead and do that, and then resume once you have it. So below, we're going to be basically graphing sine x. So the function says y equals sine x. X is your domain. It's also your angle. Y is your range, which is also the value that corresponds to the given angle, theta. Okay, so now that we got that out of the way, once again, x is your domain, that's what you're plugging in. Y is your range, that's what's coming out as a result. So once again, we're doing sine. So what I'm going to do is I'm going to say y equals sine x. So y equals sine at 0. What is sine at 0? Sine at 0 is 0. So I get the coordinate point x comma y, which is 0 comma 0. Next, pi over 6. Pi over 6 is equivalent to 30 degrees. So y equals sine at pi over 6, or 30 degrees. Sine of 30 degrees is 1/2. So I get the angle pi over 6, or 30 degrees, comma 1/2. All right, moving on. Pi over 2. Y equals sine at pi over 2. The value of sine at pi over 2 is 1. So I get the coordinate point pi over 2, comma 1. 5 pi over 6. This is a 30-degree angle that's in quadrant 2. In quadrant 2, sine is positive. So sine at 5 pi over 6 is going to give me 1/2, positive. So 5 pi over 6, comma 1/2 is going to be this coordinate point. Sine at pi. So sine at pi, the value of sine at pi is 0. So I get the coordinate point pi, comma 0. 7 pi over 6. 7 pi over 6 is a 30-degree or pi over 6 angle found in quadrant 3. Sine is negative. So I have 7 pi over 6, comma negative 1/2. Sine at 3 pi over 2. That's 270 degrees. Sine at 270 is negative 1. So I get the coordinate point 3 pi over 2, comma negative 1. Next is y equals sine at 11 pi over 6. Okay, 11 pi over 6 is at 30-degree angle in quadrant 4. Sine is negative in quadrant 4. So I get 11 pi over 6, comma negative 1/2. And finally, sine at 2 pi. So y equals sine at 2 pi. That's the same as 0. It's 0. So I get 2 pi, comma 0. And these values are what we're going to take. And the next thing we're going to do is graph the sine. So we're literally going to plot these points out. The x-axis will be the angle, and the y-axis is going to be the value at that angle. Okay, so let's check this out. So first things first, you're going to need to draw an x and y axis. So let's go ahead and draw that in here. So if I look at my x values, I have 0, pi over 6, pi over 2, 5 pi over 6, pi, 7 pi over 6, 3 pi over 2, 11 pi over 6, and 2 pi. Okay, so what I'm going to do is, because that's a 30-degree angle, I'm going to split these up into 30. So here's 0, the origin. By the way, this is my x-axis, so once again, it's my angles. So 30 degrees away from 0 is pi over 6. And then, you know, if I go in 30-degree increments, the next thing I'm going to hit here is 90 degrees or pi over 2. Okay, after pi over 2, the next 30-degree value I'm going to hit is 150, which is 5 pi over 6. Okay, after that, we're going to hit 180 degrees or pi. And then we go 30 degrees into the third quadrant. So 30 degrees into the third quadrant would be 180 plus 30, which is 210, or 7 pi over 6. Okay. And then we go 30 degrees out, and then we hit 3 pi over 2. Okay, 30 degrees, and then 30 degrees away from 360 would be 330. 330 is equivalent to 11 pi over 6. And then finally 2 pi. Okay, so I put the values on there, and once again I went by values of 3 just because that's the way this graph is going to look okay. The other values I have are the y values. So if you look at all the y values, I have 0, 1 half, 1, 1 half, 0, negative 1 half, negative 1, negative 1 half, 0. So I need a 1 half and I need a 1. I already have the 0. Okay, so I plot those points in. Now I'm ready to plot my graph. So just give me 2 seconds. I'm going to get a different color here so we can see it. All right, I'm good. So I'm going to plot the first point, 0, 0. That would be right here. Okay, the next point I'm going to plot is pi over 6 comma 1 half. So pi over 6 comma 1 half is here. Pi over 2, sine is 1. So I'm going to plug that in. And then 5 pi over 6, we go to 1 half again. And then we come down here to 1. Or 0, excuse me. We come to 0 at pi. 7 pi over 6, it's negative 1 half. And then 3 pi over 2, we get the value of negative 1. 11 pi over 6 is negative 1 half. And then we finally come back up to 0. Okay, so if I connect the dots here, this is my graph of sine. And this graph, I'm going to fix this up just a little bit so it's clear. This graph is showing one period of sine. So the period of sine equals 2 pi. We learned that in the last section. So this is showing one period of pi of a normal sine graph. I should say one period of sine is what I meant to say, which is 2 pi. Okay, so we got our graph here. Now we're going to look at it. So if we look at it, we can see that the domain is all real numbers. So I'm looking at the width of the graph. Like, how wide is it, the domain? How wide is the graph? It goes on and on infinitely. So the domain is going to be all real numbers. Okay? The range is the height of the graph. So if I check out the height of the graph, I see it goes from negative 1 to 1. And all values in between are represented. So negative 1 to 1. This, by the way, is called interval notation. So negative 1 is the smallest point, whereas 1 is the highest point, and the brackets mean that those points are included. So there you go. Okay, so let's look at the next page, and please refer to your graph and your notes to answer the following questions. So once again, your graph shows the period of 2 pi. By the way, period can be represented with a letter t, and you can say t equals 2 pi. And we're going to actually learn a formula in a couple minutes that deals with t. So the properties of sine. The domain is all real numbers. And if you want to put that in interval notation, it's going to be negative infinity to positive infinity. Okay, the range is the height. So the range goes from negative 1 to 1. Sine is odd. We learned that last section as well, which means it has symmetry with respect to the origin. Sine is periodic with a period of 2 pi. Once again, it starts repeating at 2 pi, so you're going to see that same wave again and again and again. So let's just do 2 pi here. I'm just going to show you quickly. It goes like that, and then it's going to do that again. So it can do that indefinitely. You know, it's not the prettiest thing in the world, but I just quickly want to show you what that looks like. The x-intercepts, that's the point where it crosses the x-axis. We see it crossing at 0, then it crosses at 180, and I'm talking about the x-axis, by the way, and then it crosses at 360. So putting that in radians, it crosses at 0, so that point is 0, 0. Then we have pi, comma 0, that's the next x-intercept, and then we also have 2 pi, comma 0. So those are the x-intercepts. The y-intercept occurs only at the origin, which is 0, 0. The maximum value is positive 1, and if we look at our graph, we see that it hits 1 when we have pi over 2. So it occurs at pi over 2. So my angle is pi over 2, I get the value 1. The min, or the minimum value, occurs at negative 1. And it occurs at 270, which is 3 pi over 2. Okay, so those are just some facts about the graph. And like I said, when you see it, a lot of things start making sense. Like the domain, all real numbers, got it. Range, negative 1 to 1. Sine is odd, and it's periodic with a period of pi. 2 pi, excuse me, period of 2 pi. All right, so the next objective is to graph the function of the form a equals sine wx. This w is actually not called w, it's called omega. Okay, and the a is called the amplitude. Okay, so the amplitude will give us vertical stretch, or it gives us compression. So here's how this works, is if a is positive, so if a is greater than 0, you're going to get a stretch. If a is less than 0 or a fraction, you're going to get compression. Omega gives us horizontal compression or stretching. So if omega is positive, so I'll put omega is greater than 0, then what happens, you actually have compression. And we'll talk about this in a minute. If omega is less than 0, then you have stretch. Okay. If you have a negative in front of your sine function, it could even be in front of, if you have an amplitude. At any rate, if you have a negative in front of there, you have to flip the whole entire graph over the x-axis. This is called reflection about the x-axis. So let's look at our first one. Y equals 3 times sine x. The 3 is the only thing we have to worry about, otherwise this looks normal. The 3 represents the amplitude, so A equals 3. What does this mean? That means that every value that I have for the graph that we just did, we're going to multiply that by 3, because this says 3 times sine of x. Okay, what I want you to do from here on out is there's 4 key points for the original sine graph. They are pi over 2, pi, 3 pi over 2, and 2 pi. Those are your 4 key points. And once again, our graph goes up to positive 1 and negative 1. So x is my angle, y is my value at that angle. Okay, so here's the graph. What the heck is this thing doing? So my graph is, it looks like this. And actually it doesn't, sorry. I don't know what's going on with the pen. Okay, it's kind of laggy. There we go. Okay, so we got these key points here. Once again, at 0, I have 0, 0. At pi over 2, I have positive 1. At pi, I have 0. At 3 pi over 2, I have negative 1. And then at 2 pi, I have 0. So once again, you have to remember what this looks like. This is y equals sine x, okay? That's never, ever, ever going to change unless you manipulate it. Now we have an issue. We have we have the amplitude equaling 3, which means all of my points are getting multiplied by 3. So let's redraw the original graph. I'm going to do this in blue. Okay, so the original graph is going to be -1 to +1. I'm going to draw this out up to 3 because I know I'm going to have to multiply all my values by 3, and my maximum is +1 and my minimum is -1. So if I multiply +1 by 3, I get 3. If I multiply -1 by 3, I get -3. So that's why I'm doing that. Okay, so the original graph, once again, we have pi over 2, pi, 3 pi over 2, and then 2 pi. Okay, so the original graph looks like this. 0, 1, 0, -1, and then back up to 0. So let's smooth this out a little bit. Okay, so that's my original graph. All right, if I apply the transformation, now I have to deal with omega. Once again, I'm telling you that you multiply everything by 3. So 0 times 3 is 0, right? 1 times 3 gives me a +3. 0 times 3 is 0. So right now I have this graph so far. At 3 pi over 2, my value was -1, which I made that a little bit off. So let's fix that. It shouldn't go clear down to -2. I'm going to fix the graph really quick, guys. So give me a second. All right, I would re-record this, but I'm kind of short on time. So I'm going to have to deal with this, unfortunately. There we go. I just fixed it. So that should only went down to -1. Anyways, now let's deal with the amplitude. So once again, what were you doing? Multiplying everything by 3. So I'll start at pi. 0 times 3 is 0. All right, I have -1 here. -1 times 3 gives me -3. And then 0 times 3 is 0. So the red graph shows y equals 3 sine of x. So that is what you want. Okay. All right, I'm actually going to save this problem for the next video because we're already at 17 minutes. I'm going to stop here. So you just witnessed part 1. You got to watch part 2 and probably part 3 as well. Okay.